Well, hello everyone. Welcome back to Adrian's Digital Basement 2. On today's video, I'm going to be revisiting this Sharp television that I recently did an S-video mod on the main channel. And in this video, what I want to do is I want to investigate the I2C bus on this set to see if I could possibly intercept communication or maybe force the jungle IC to disable or enable the 3.58 megahertz trap on demand based on, say, the position of the switch for whether I'm using external S-video mode or composite decoding, where the chroma decoding is happening inside the jungle IC. If you haven't watched the video on the mod on this TV yet, I recommend you do that because, of course, I'm going to be talking about a bunch of stuff from that video, including the effect the trap filter has and why I want to turn it off versus turn it back on again. Now, I alluded to this a little bit in that main channel video, talking about the fact that the jungle IC, which is IC201 in the middle here, communicates to the microcontroller IC2001 over I2C bus, and it's the microcontroller that controls the various functions of the jungle IC. Now, at the time I'm making this video, and when I made the video on the S-video mod, I didn't have access to the datasheet for the jungle IC. Not sure if that's going to turn up or not in the meantime, but usually the datasheet for these jungle ICs actually lists out all the I2C command registers, addresses, and all the various functions of all the commands. So it allows you to fine-tune all the capabilities of the jungle IC. Without the datasheet, I don't really know anything about the I2C communication. All I know, though, is that clearly the microcontroller is communicating with the jungle IC, and it's probably bidirectional communication because it's like checking on the status of the functionality of the TV to make sure it's actually operating. If there's a problem, say the deflection isn't running properly, or the microcontroller expects the jungle IC to be running and communicating on the bus and say it's not, then the microcontroller will shut down the TV. It has control of the power supply. Now, this is the block diagram for this particular TV, and obviously it's going to be different than any other television. You have to look at the service manual to see its block diagram. But if we start with the microcontroller, and we want to see how it communicates with everything, I think pin 33 and 34 are the I2C communication channels. SCL, serial clock, and SDA, serial data. That's the I2C bus. So it comes out of the microcontroller, it goes to the EEPROM, or EEPROM, and that's where all of the settings are stored for instance, like the last channel you were set to, volume, all the settings for the video mode, and then all the service mode settings, like the bias for the CRT and all, geometry settings, stuff like that. It's all stored in this EEPROM. If the EEPROM fails, then I think what happens is, none of those settings are going to save. And I saw somewhere else in the manual, if you have to replace the EEPROM so it's blank, there is a way to enter service mode and then reinitialize it. It basically puts the default values into it. So the EEPROM's on the bus, and then obviously the jungle IC itself is connected to 2728. It's on the I2C bus as well. And if we look at the I2C bus, it makes its way up to the Varactor tuner. So the tuner is completely controlled by the microcontroller entirely over I2C as well. Now, when we look at the block diagram, it just shows these 4 devices that are on the I2C bus. Doesn't actually show anything else. There's actually something else that might help us out here. So if we go over to the schematics and we take a look at the I2C bus, and I know it's going to be on here somewhere, the important thing is that on the back of the set here, there's a small diagnostic connector, and it has the SDA and the SCL lines available, along with the AC and EXT signals. Whatever those are, don't know. I2C is a bus that can have multiple devices on it. They have addresses, things like that. So obviously this connector is there for diagnostic capabilities. Potentially at the factory, they connect to it to program the EEPROM with the values that they think the TV needs. Perhaps when they're doing the assembly of the TV, they kind of run through some quick settings, maybe with some special calibration tools, and then it loads those settings into the EEPROM. Not to mention, it's potentially possible that the microcontroller actually has some programmability. You can load code into it or something, and maybe they do that at the factory as well. Or there's special diagnostic commands in the microcontroller that they're able to interface with for diagnosing this television. Maybe it can generate some calibration graphics. I mean, who knows what it can do. This is the actual microcontroller, though, IX2942CE16K says. Now, on this extra diagnostic connector, the EXT signal just goes directly to an EXT in signal on the microcontroller, and it looks like it's normally hooked up to 5-volt rail, and potentially you ground this. So that pin will get 5 volts normally, and I'm assuming this EXT maybe sets this into like a programming mode or a special mode, and you would ground that signal. since I don't have any idea how that might work, I don't want to potentially brick this TV, so I'm not going to touch that signal. There's also an ACK signal, acknowledge, it sounds like, and if we follow that trace, that makes its way down here to what is labeled external LED. So this TV has provision to have an LED on the board, actually a dual color LED on the board. It's just not populated. This main board is almost certainly used in a bunch of other Sharp televisions, even larger ones like 19-inch TVs and stuff like that. Maybe some of those have an LED. Maybe it indicates that you get stereo sound. I can see provisions for additional modules that aren't installed in this board, and I'm assuming there's like a stereo sound decoder for MTS stereo. And this definitely has audio input jacks for right and left audio, and I can see a connector for another speaker, but none of that is populated on this set. So again, used in some other case. So maybe that external LED is used for like diagnostic capabilities and stereo sound and maybe other functions as well. But in this case, it is wired up to go to that connector. So I'm assuming maybe when you do certain stuff over the diagnostic connector, you get flash codes or something like that from the microcontroller. If anyone has any information or worked on Sharp TVs in the past and has a little bit of knowledge about what those extra signals are used for, yeah, please let me know. It's my intent in this video to try to snoop the I2C bus while the TV is running with a valid signal so we can look at the normal I2C communication that's happening. And then perhaps if we go into the service mode, which is all happening inside the microcontroller, and we turn that trap on and off, perhaps we can see it sending the command over to the jungle IC to turn it off and on. If there's not like a ton of other commands that are just making it really difficult to see, then maybe I can replicate that and I can use an Arduino hooked up to that same diagnostic port to actually send that command. Now I've done this a little bit in the past with other TVs, and I found what typically happens is that the microcontroller is continually sending commands over to the jungle IC. Like it's completely setting it up constantly. And with this other TV, which I forgot who made that TV, but if I changed any of the commands, because I did have the data sheet. So say I don't know, changed it to an RGB input, after about a second, the microcontroller would send all the commands to the jungle to set it up again, and it would just switch back to its original mode. So I couldn't make any of the commands stick, and I could send them continually, but the microcontroller and the Arduino were just constantly fighting. That might be the case here, but I have absolutely no idea how Sharp TVs work in this regard. I've never looked into this. The jungle IC and the microcontroller are made by Sharp. Of course, the firmware that's running on here is made by Sharp. This TV itself is actually made by Sharp. It's made in Malaysia. It's not Japanese made, but it's all an in-house design. It's not like they outsourced this to Funai or some other company. A lot of other TVs were what was happening in the early 2000s. This TV was from, I think, 1997, and the design date backs even earlier than that. So depending on what's going on the I2C bus, it can be somewhat high speed, so it's not something you can just necessarily dump over serial. So we're going to first start by using a logic analyzer to connect up to the diagnostic connector. You could just see it right there. Sorry, it's a little blurry, but that's the connector. I've already gone ahead and figured out that the ground pin is the one closest to the tuner. So that is pin 5, and that one, which I put a little mark on, is pin 1. I'm going to hook up to the ACK and external signals as well, so I'm just going to use all 4 of these wires. Well, actually all 5, because the black cable is ground, which of course we need as well. So the set is currently off, and it's completely unpowered at this time. Okay, logic analyzer is hooked up to the main board, and one thing I want to do is I want to get video actually feeding into this. So I'm going to put the board back into the case. That way I can plug the video cable into the front connector. Okay, so everything is connected. I have the board supported on that little roll of Kapton tape. And this is the DS View software. And you've seen me use this before while I was trying to fix the Zenith ZT1. This has an I2C decoder in it, so I've turned that on, and I've already configured it for SCL being pin 4 and SDA being pin 3. And we have access to the ACK and the external signals as well. Now the question is, let's see what kind of sampling mode this is. 6 sample mode. I think we can do, yeah, we can do stream mode. And I think it's very typical. I2C buses run at like 100 to 500 kilohertz. So we'll just use it at 1 megahertz. That should be good enough. And if we have to make it faster, then we can do that. All right, so I'll just set this to 1 minute because since it's streaming over USB because it's low bandwidth, I'm going to hit start and it is now capturing. I'm going to power on the set, but I'm not going to turn it on. I'm just going to power it on. And there we go. We had a little bit of activity right away on there. And that would have been the microcontroller booting up and it would have been loading its settings out of the EEPROM. So all 4 of these lines went to 5 volts, which is kind of what we'd expect, right? And if we zoom in here, we should be able to see what's going on. So address write A0. I'm gonna have to start taking some notes here because I have a feeling it'll be a lot of addresses and we'll just need to kind of keep track of what's what. Now, I really don't know that much about I2C, so I might have things wrong here, but I'm just gonna assume that this is writing to address 0. And I think what comes next, how do I scroll in this? I think I used the Alt key. Yes, there we go. Data write. So I think something wrote to A0 and it wrote 54. And this ACK is part of the I2C protocol. Okay, and now it's reading from address A1, which I'm also thinking is probably going to be the EEPROM. And we can probably go look up the datasheet for that chip actually, because that's probably a Jelly Bean part. Okay, so I was able to export all this information to a CSV, which is great because we can analyze this data a little bit more easily. There's a whole lot of reads and writes from A0 and A1, which, like I said, oh, look at this. It was trying to write to some other address, 88 as well. I just did a quick grep, and it looks like all of the reads happen to address A1, and then all of the writes happen to A0, except right at the end there are 3 writes to 88, which makes me think it's trying to write to the jungle IC, and the jungle IC is not online. Or maybe the tuner. Both the tuner and the jungle aren't online, so that could be what 88 is. Now, we can kind of be sure if when I actually turn on the television, so it's running, and it boots up the jungle IC and the tuner, which aren't powered up right now because the TV's off. Right now, in this standby state, only the EEPROM and the microcontroller are running. Everything else is actually off. I'm thinking that if I have the video input selected, we're not going to really see much activity to the tuner. If I switch over to the TV and I start changing channels, then we're going to see reads and writes, or maybe just writes to the tuner. Actually, I think it can read from the tuner because I think it can read like signal strength and stuff like that. And it's used for auto scanning all the channels. Either way, we know we're getting a good read off the I2C bus, which is the important part. Interesting thing is now that we know that the EEPROM is potentially A0 and A1, we could hook up an Arduino and read out every value from the EEPROM and potentially change settings. So for instance, if there was some like secret settings in there, we could alter them to add some functionality to the TV that's not available through any of the service menus and stuff. That would potentially be possible. Now, incidentally, I was thinking that the EEPROM might be just a Jelly Bean part, but it looks like it's actually a Sharp part, IX2447CNI, or 1. Although, you know what? I just had a thought. So these are the part numbers from Sharp, IX2447 whatever, but this actually shows us the actual part number. It's an ST micro. Oh, okay, cool. And you know what? I thought this was the part number for the jungle IC, but it's actually this TA part, which is a Toshiba part. You know what? I never actually looked at the part itself to see what it is. Maybe it's this TA part. You got to be kidding me. I think this is the jungle IC. I thought it was a Sharp part, but it's just a Sharp part number. It's actually made by Toshiba. Oh, this probably has all the I2C commands right in it. There's that 3.58 megahertz trap filter circuit bus on off. And look, there's the analog RGB input, there's the chroma input, there's the Luma input, there's the AV switch output. Very interesting. Now, I was really curious to know in the video on the TV, I said that the sync information wasn't extracted from the Y input. There's the trap. But let's see where this goes. Black stretch, smoothing, DC restoration, YDL, that's like a delay line. And that makes its way to sharpness control, contrast, brightness, blah, blah, blah. Yeah, all the way to RGB output through a matrix. Okay, so the sync information is extracted earlier on, probably right here. So there's external input, that's the front video input. There's the TV input, that's the tuner input after it loops around. Makes its way to the H separator. Yeah, this is the sync output here. So this V-sync, H-sync, all that kind of stuff. Okay, so that's why inserting the Luma into the Y input did not work for the sync information. It is done earlier on. But the good thing about these data sheets is they really show everything there is to see about how this thing works. Now, I was under the impression that the RGB input, I mentioned this in the other video, was running in 5-volt analog mode. It said on the schematic that it was TTL input, but it says very clearly analog RGB, and I never actually measured it to see if it was 5 volts or not. I mean, it showed that on the schematic that it should be like 4.8 volts or so, but I wouldn't be surprised if this is clamped with diodes. Therefore, even if you put more than, you know, the regular analog voltage into it, it doesn't hurt it or whatever, because it clearly is, well, I think it's operating that way. How interesting is that? And look at this. Here's the I2C table, and look at the address, 88. So that's exactly what was happening at the end of that capture. It was actually trying to talk to the jungle IC just to see if it was running for some reason, but it's not running, it's powered off. So it obviously just goes into a wait state and just sits there. And this is what I was talking about, subaddress 0, data bit 7. That's the trap. And then this would be the color control. So this would be what you would set up in the menu, or I'm trying to think of how this works actually. Yeah, I have a feeling this is the color control. So the microcontroller takes what you have on the on-screen menu when you set color, and also what you have set in the service mode, that sub color, and it recalculates the value, and then it sends it to the jungle IC. We have a bit for C filter and A switch and BLK, whatever those are. Unicolor, don't know what that is. Brightness and tint and color, that's obvious. Sharpness and mute. Vertical phase, horizontal phase, those are things we see in the service menu. Audio attenuator, that's going to be volume control. We have some extra configuration bits here. We'll have to look at what those are. V switch, whatever that is. AFC, automatic frequency control. WPL, whatever that is. Vertical amplitude. This is all stuff that we see inside inside the service menu. V fixed, I don't know. You know what that's interesting. V fixed. A lot of these chips support actually running at 50 hertz. They just don't support decoding PAL color, but they can run at 50 hertz. And I think VFix, if I'm correct, we'll have to look further down to see what that is. But I have a feeling when you set that bit, it fixes it to run always at 60 hertz. But if you turn that off, then the chip is able to run from like 49 to 62 hertz or something like that. And that will allow this TV to actually potentially work. And well, if you have RGB input into this thing, then you can do 50 hertz RGB from a PAL machine. But you can also do NTSC 50, which is like a custom mode where you have NTSC color on a 50 hertz signal, and you'd have to fiddle that bit. The VCO stuff, that was in the service menu, and then we have RGB cutoff gain, that stuff that was all in the service menu. All right, so here are these other things. There's the trap on and off, which we have access to in the service menu. Then there's a chroma filter, bandpass, or takeoff. Don't know, we don't have access to that in the service menu, but that's something that is configured over I2C. AV switch, TV mode or external. Okay, so that just sets which input it's running at. BLK on or off. Don't know what that means. Not very descriptive. Mute. Okay, we do have access to this, so it can either stop the vertical, so that basically shrinks the entire image. You can turn off the luma, so you just have chroma, and then we can also just, well, make that run normally. And H-stop will just turn the TV off entirely. I think the TV is still kind of running, but obviously when you do H-stop, it shuts everything off, including the jungle IC, because the jungle IC is powered off the flyback, off the horizontal. And automatic frequency controls, that's be for the tuner, I assume. WPL, still don't know what that is. And there's that V-fix mode. This is what I was talking about, normal mode and V frequency 60 hertz fix. Okay, so you can configure some extra outputs, AFT voltage, test mode, blue output, half of RFC AGC. So bits for test mode used with these bits, I don't know, some extra test stuff. And then you have the ability to read from this chip. So you can write to this chip at address 88, and then you can also read from it. It's just basically a status byte that comes back. So these 8 bits. X-ray, I think, means that it's either operating normally, or actually says right here, X-ray off, X-ray on. I assume one means something is wrong with the TV and better shut down immediately. So that's why the microcontroller is constantly reading from the jungle chip, because it's going to be checking these bits. V-lock, H-lock, you know, these bits, I think it tells the microcontroller that it's locked on, I guess. Killer. So this is the color killer circuit. Basically, if there's no color, if you're inputting monochrome into the jungle IC, it's able to detect that there's just no color, period. And the thing is, the microcontroller can be smart. And when it gets that bit set, then what it can do is it can automatically turn off the trap, which will give you a much sharper resolution screen, especially if you're using like an Apple II in text mode, or even just inputting a monochrome signal into the set. Disabling that trap. The trap is only needed for color video, so it should be turned off otherwise. And that is the microcontroller's responsibility. And there is this bit available, the D3 color killer on, I think would be set when there is a monochrome signal input into the thing. So it's the microcontroller or the programming on here that's just lame, and it doesn't actually take that into account. IF lock, so that must be something to do with the tuner, and automatic fine tuning, and power on reset. So I don't know, I guess if the thing tries to reset multiple times, then this will be set to second, and then it knows there's a problem or something. Then here is the format for writing to this chip. So slave address, I think we determined, what did I say the address was? It was 88, we already saw that actually. And then it's gonna have a sub address and data. So if we go back to this table, here's the sub address, 00 through 0F, and then here is the 8-bit value for each of those entries. So the way you write to it is you have this format, you have the slave address 88 there, you have sub address like 00, and then to change that trap bit, you can't just change that one bit, because remember, trap was part of color. So you have to rewrite this entire value. So unfortunately, that means if we're going to try to override the trap value, we'd either have to listen for the I2C bus to see what the current trap value is coming from the microcontroller, or sorry, the current color value, and then use that to change that other bit. I don't know. We're gonna have to do some more snooping once the set's powered on so we can kind of see what's going on exactly. Now, incidentally, the analog RGB input, check this out. It says analog, but look at the voltage range. Minimum 4.4 volts, max 5.4 volts. Well, that's not analog input, that's TTL. So what kind of a lie is this thing talking about analog when it's obviously digital? And then when we looked at that table with all the I2C commands, there was nothing to do with RGB there. There was no way to change the mode between, say, analog and digital. But I mean, this doesn't lie. It wants 4.9 volts or 5 volts on the RGB input. So that means you have access to 8 colors, and it's not analog at all. Wow. Anyhow, we found what we're looking for. So we're looking for slave address 88, sub address 00, and specifically data bit 7. That's the trap setting that we're looking for. We also have the C filter, which is 01, and we're looking also for D7. So we need to see what that's set to. That wasn't something we could even configure in the service menu, but it's something that maybe is worth kind of playing around with. I think it said it was called the chroma filter. And just for completeness, here is the serial 1K EEPROM. It's 128 bytes in size. And just for my future knowledge, I went ahead and I saved both data sheets for the EEPROM and also the Jungle IC into my Google Drive folder where I have all the other information for this TV. All right, well, I think what it's time to do now is start the capture again, and I need to turn on this television. We need to see it actually run. Here we go, 3, 2, 1. Okay, it is running, and look at all the activity. So just as I suspected, I have a feeling it's continually either pulling the Jungle IC or it's rewriting its registers over and over and over again repeatedly. Do we have an image? Yes, we have a normal image on there. It's not color right now because it's hooked up to the Luma output. I could hook up the Chroma output. I'll forget it. I'll just turn off the TV. Power off. There we go. It went away. All right, this capture is loaded into the spreadsheet here. Now the data write 88s, we know what that means. That is the slave address where it's writing to the registers. And then the data write 3 is selecting register 3, which let's see what that is. That was this one here, a unicolor and the BLK input. And then it's writing 00. And then register 2 is getting 80 written to it, and so on and so forth. So we're looking for sub address 00. There it is right there. So data write 00, and then it's writing B4 to that particular address. And converting B4 into binary, that is D7, that 1 there. That is the most significant bit. In fact, we can do this. There it is. It's that one right there. And remember, the rest of these are the color setting. And let's see, when C trap is set to 1, is it on or is it off? 1 is off. I think that pretty much matches, because I'm quite sure I left this in the off setting. It's in the high resolution mode. And remember how I said that I thought that it was trying to read values out of the chip? It doesn't look like it's actually doing that, because it has reads and writes. We know those are the EEPROMs. And then it's just writing to the Jungle IC, and that's it. That's it. There's nothing else happening. Of course, I never went to the tuner, so we don't see any tuner activity. Interesting. So I was curious, is how much is it writing to that chip? Oh, it's just constantly writing to it, just all the time. So that pretty much tells us that we cannot just change the value with an Arduino. It is not going to work. I mean, we could try to just control it ourselves, like disconnect the microcontroller, but I don't think that's going to work because there are output pins on the jungle IC that it's monitoring and other things. I don't know. I don't know. We need to alter the programming on the microcontroller or somehow dump the code that's on there and then run the TV ourselves to potentially make this possible for us to switch that on and off ourselves. It'd be kind of interesting to know if changing the value in the EEPROM would somehow get it to reread that value out of the EEPROM, but I doubt that. In fact, if we change this to reads for the EEPROMs, yeah, there's one. The whole time I had the TV running, which was what, like a minute or 30 seconds or whatever it was, it read from the EEPROM a single time. And let's see how many times it wrote to the EEPROM. Okay, it wrote to the EEPROM twice, probably about like the power on state or something like that. And it read from it one time. But it wrote to the jungle IC a zillion times. Absolutely a zillion times. It looks like 1,300 times it wrote to the jungle IC. I did a little bit of analysis in the capture file, and unfortunately the brightness trap and the contrast C filter addresses are written to about every 90 milliseconds. So yeah, that's impossible for me to try to overwrite those, because if I change it, it'll just instantly change back, you know, within 100 milliseconds or so. And I could continually hammer that address to try to change it, but it would just keep alternating back and forth. So yeah, unfortunately, there's really no way around this. I cannot enable and disable the trap and the C filter by using an Arduino. That's a shame. I was hoping it would just like write to it once and then it would leave it alone and I could alter it, you know, and then it would be fine until I did anything on the TV and then it would switch back. But that's fine. We could just, you know, keep changing it periodically, but not at that rate. That's just not possible. I suppose what we should do next is start a new capture, and I'm going to turn on the TV again. And this time I'm going to turn on, so there we go, boot it up. I'm going to change to the tuner. So let me look at the TV. There it is. Oh, look how it kind of has little gaps. And let's see what that does. We should have an additional address. And I went back to the input there. Okay, and I did a quick grep. And look, here are writes to C0. A0, that's the EEPROM. 88 is the jungle IC, and then we know C0. Yeah, that must be the tuner. So it's writing to the tuner. Very interesting. So that's our last address that we were not aware of. Okay, well, there we go. This video was a little bit of a bust, but it was just interesting nonetheless. I gained a little bit of knowledge about how this TV works, and unfortunately, I can't override the settings that I wanted with an Arduino. I thought it would have been really clever to use GPIO lines on the Arduino to hook it up to that toggle switch, because the switch has unused pins on it. It's a double pole switch, and I'm only using half of it. So I could have used the other half for the GPIO to switch between 5 volts and ground, so that the Arduino could know which setting that switch is in and then start hammering that register to disable the trap or enable the trap, for instance. But it seems that Sharp, when they designed this TV, they're just hammering those registers over and over again, which frankly is maybe what you need to do. I actually don't know if that's just normal for these or what. Like, can you just set them once and leave it until you change it? Why does it hammer them over and over again every 90 milliseconds? That seems a little unusual, but if anyone knows more about the design of these types of TVs, maybe that's normal. But I can tell you that other TV I worked on, like I mentioned, it changed the values or refreshed them maybe at once a second or once every couple seconds. It wasn't as frequent as this TV is doing. Still means that we're basically totally out of luck for trying to manually control this TV, which is definitely a bummer, but I'm still happy that I did the S-Video mod, because I still think that S-Video mod was worthwhile, because going into the service mode is a little bit of a pain, but it's not that much of a pain. And it's always actually kind of fun to break out this logic probe or logic analyzer and just complain that I unplugged it without shutting the software down. So there we go. If you liked this video, thumbs up. If you didn't, you know what to do. Hopefully this was a bit insightful. And if anyone has any ideas of what maybe we can do to try to make this TV better, then I would really, really appreciate it. I need to go update the description on the original video to say that I did find the datasheet. Once I just looked at the part number lookup, it had the TDA part number right there. Oops. Anyhow, it wouldn't have really changed how I worked on the S video mod on the last video, because that was all just analog electronics that I was working on. And yeah, like the video, thumbs up, subscribe, all the usual YouTube junk. Thanks to my supporters. Their names go on the side of the screen. And I guess that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.